respect to the ground. So let's draw a picture. So that's going to be the ground, and let's draw a picture of a train. Now on this train we see that John is walking east. At 3 meters per second. So we could say that John's velocity relative to the train is positive 3 meters per second, or rather miles per hour. Let's fix that. But what is his velocity relative to the ground? So an observer who is standing on the ground, what does he see? An observer standing from the ground, he sees the train moving at 50 miles per hour to the right relative to him. Now, in addition to that, John is walking to the right. He's walking 3 miles per hour faster than the train. So John's velocity with respect to the ground as viewed by an observer is actually going to be positive 53 miles per hour. It's going to be the sum of the train and the velocity because they're both moving in the same direction. Now for those of you who like to use a formula to see the calculations, here's what you can do. John's velocity with respect to the train is going to be, or in other words, VJT is going to be VJ with respect to the ground minus VT with respect to the ground. So VJT, John's velocity with respect to the train, that's positive 3. We're looking for John's velocity with respect to the ground. And the train's velocity with respect to the ground, we know it's positive 50. So what we have is 3 equals VJG minus 50. Well, to get this answer, we need to add 50 to both sides. So moving negative 50 to the other side, it's going to be positive 50 plus 3. And that's how we get VJG is positive 53. So that's how you can use the formula to get that answer. Now let's move on to part B. What is Sally's velocity with respect to the ground? So Sally is moving west at 4 miles per hour, and this is while she's on the train. So Sally's velocity with respect to the train is negative 4 miles per hour. It's negative because she's moving to the left. Now, what is her velocity with respect to the ground? Well, we could use the same formula or something similar to it. So VST is going to be VS with respect to the ground minus VT with respect to the ground. VST is negative 4. VSG is what we're looking for. And the velocity of the train with respect to the ground is negative 50. So we need to add 50 to both sides. So it's going to be negative 4 plus 50, and that's going to equal VSG. Negative 4 plus 50, that's going to be positive 46. So to an observer on the ground, John is moving east. So John will appear to be moving faster than the train. Sally's moving west, so to an observer on the ground, Sally is going to be moving slower than the train. She's still moving to the right with respect to the observer, but she's moving at a slower rate relative to the train. Now let's move on to part C. what is John's velocity with respect to Sally? So we're looking for VJS, John's velocity with respect to Sally. Using the formula, it's going to be John's velocity with respect to the ground minus Sally's velocity with respect to the ground. And we have those numbers. It's those two numbers. So it's going to be 53 minus positive 46. 53 minus 46, that's positive 7. So John's velocity relative to Sally is positive 7. What that means is that his velocity is 7 units greater than Sally's velocity, which makes sense. Positive 3 is 7 more units than negative 4. Now we can also get the same answer using this formula. Instead of using the ground as the common reference frame, we can use the train as a common reference frame because both John and Sally are on the train. So VJS can also be calculated using this formula, VJT minus VST. It works the same as long as we use a common reference frame. So VJT, that's positive 3, minus VST, which is negative 4. 3 minus negative 4 is the same as 3 plus 4, and it gives us positive 7 miles per hour. So that is John's velocity with respect to Sally. Now what is Sally's velocity with respect to John? All you got to do is switch the sign. So VJS is going to equal negative VSJ. So that means it's going to be negative 7 miles per hour. And of course we could use the formula. VJS is going to be, VSJ is going to be VS with respect to the ground minus VJ with respect to the ground. So VSG is 46 minus VJG, which is 53, and that will give us negative 7 miles per hour. So that's Sally's velocity with respect to John's. And that's basically it for this video. Hopefully it gave you a good idea into the concept of reference frames. So whenever you describe an object's motion, its velocity, you need to describe it with respect to something, and that something is the reference frame.